Welcome to this video. I'm going to be going through some pseudocode examples from the GCSE AQA papers of 2018, 2019, and November 2020. Example of different questions. We're going to start on basic questions and then we're going to build up the complexity as time goes on. What I suggest we do is that you can pause, attempt this question, and then you unpause, and then I'll start going through what I think the solution is. We should work together like that. My advice wouldn't be just to sit back and watch. Is more engaging you make it, the more you try and interact with it, the better it will be. So, without further ado, let's get started. So, the pseudocode in figure 1 assigns two string values to two variables. So, first variable is named title, and it's storing the value computer science. It's a string because you can see it's between these quotations. The second variable is identified as level. So the name of the variable is level and it's storing GCSE. And remember, the arrow assigns the value to it. This is trying to make sure you understand the difference between having a name of a variable and the thing it's storing. So let's get started looking at the first thing it's asking you to do. So it's saying shade one lozenge, that's one of these things, that shows the length of the contents of the variable level. So level's this one. And the length will be this. So remember, it's if it was identifying the position, it would be 0, 1, 2, and 3. But there are 1, 2, 3, 4 letters long. So the first answer will be 4. Let's continue. Shade one lozenge that shows the result of concatenation. Now, concatenating is when you stick strings together. So when you use a plus with a string, remember, it doesn't do mathematical add. Instead, it sticks it together like glue. And it says concatenating titles, so plussing title to level. So something on the lines of title plus level, that sort of effect. Now, you might be reading it and going, okay, well, I see it's all lowercase, so it's that one. And it's GCSE, so it's that one there, because that reads the best. But remember, that space there is also a character. Is there a space at the end there? No. Is there a space at the beginning there? No. So when you stick it together, there is a space between computer and science. You see it's up here. However, the rest is all glued together. So it would be the bottom one. If you wanted to introduce a space, you either have to add a space in here, or put a space here, or I guess here. Okay, onwards and upwards. Shade one lozenge to show which of the following strings is a substring. So that's a string that fits inside it. So a substring is any small part of it, of the variable title. So title is here, so that's the full string. A substring, well, put would be a substring. Omp would be a substring. Computer would be a substring. So comp ski. Now, comp appears here and ski appears here, but they're separated by uter and a space, so it doesn't work. Pewters, well, you got pewter, but then there's a space and an S, so what would be that? Ski, so there you go, SCI, that definitely is a substring. And then terra ski, again, there's a space, so it's this one here, it's ski. So a substring is a continuous list of characters inside it. And then finally, the Unicode character of title 0. So remember, we talked about this before, that although, for instance, level is 4 characters long, G is at position 1, C is at position 2, S is at position 2, and E is at position 3. It'd be the same here. That's 0, 1, 2, 3, etc. So let's have a little read of the question. The unit character of title 0 is C. There you go. Is 99. So when you turn it into the ASCII, it's 99. Shade one lozenge to show the Unicode character of the level 3. So level 3 is 0, 1, 2, 3, E. So if C is 99, what's E going to be? Well, D, remember, these are all continuous. So whether it's ASCII, which is 7 bits, all of them are one after each other. And if you remember Unicode, for when you want a bigger character set, the first 127 characters are the same as ASCII, so that you can it's more compatible. So C is 99, D would be 100, and in this case, E would be 101. So in that case, it's going to be this one, C, which is 101. Okay, continuing on, another basic question, mainly looking at things like inputs, outputs, assigning a variable, sometimes with selection if statements, those sort of problems. Let's have a look at this one here. So a cake recipe uses 100 grams of flour and 50 grams of sugar for every egg used in the recipe. Okay. Figure 3 shows the first line of an algorithm that will be used to calculate the amount of flour and sugar required based on the number of eggs. So this thing up here being used. The number of eggs is entered by the user. So that means that user input, so the user types something in. Remember, the arrow is then assigns it to the variable eggs used. Okay. Shade one lozenge to show which of the following lines of code correctly calculates the amount of flour needed in a gram. Now, remember up here we said, it said a cake uses 100 grams of flour and 50 grams of sugar for every egg used. So this is for the amount of flour needed. This is kind of abstraction. So the crucial thing we're looking for here, that's removing the unnecessary detail and keeping what's important. Each egg requires 100 grams of flour. So the key here is the number of eggs used. If we times it by user input, it's what the person's typed in. But eggs used has already been taken as user input. So if you had eggs number used times by 100, it will give the amount of flour. So that seems right. The times by 50, well, that will give the amount for sugar. But we want to know the amount for flour. So it's this one here. Next question. Shade one lozenge to show which programming technique has been used in all of the lines of code. Okay. So assignment is assigning a value to here. The other thing that could happen is that you could be using the sign equals, and that is comparison. So that assignment is assigning a value, equals is comparing one thing to another. Indefinite iteration, so that's when you're using a loop, but you don't know how long it's going to go on for. So that would be kind of a while loop or do until, some kind of logic. Maybe how many times do you have to repeat until the password is correct? That would be indefinite. Nested iteration, if you remember, so that would be iteration, so that would be a loop. And nested is when you've got a loop inside of another loop. That's what nesting is. And selection would be if and else statements. So no if and else here, no nested iteration or iteration of any kind. It's assignment. So it's these things here. It's assignment is the answer for this one here. Okay, I've kind of chopped off a bit too much here, but it gets the general idea. If you remember, one of the crucial ideas with variables is that they belong to different data types. Now, the subroutine in figure 10, we can't see it, but uses the values true and false. So there's a certain data type that is true and false, and we'll try and remember that. And it says each element in the array board has the value 0, 1, or 2. A bit of a recap. True and false. Do you remember what that is? It's a Boolean. So this is a Boolean, spelt like so. You can only store the values true and false. Now, 0, 1, and 2, well, that's going to be one of two things. So there's numbers where it's 3, 9, 10, whole numbers. But there's also numbers like this, 2.6, 7.1, 2.33, where there's a floating point. Whole numbers, that's integer. If it's got a decimal place like this, well, the generic name is a real number, but also acceptable will be, for instance, the phrase float, short for floating point. See here, they're all whole numbers, so the answer would be integer. That's a little bit of a recap. Let's remember what some of the other ones are. What have we got missing? Well, if we just had a single letter like C or X, etc., that would be a character. What else have we got? Well, of course, we've got things like Bob, for instance, where it's a bunch of characters strung together, and we call that a string. And the one we got missing, of course, was the one we've already done, which is Boolean. Okay. The developer has taken the overall problem of the game Battleships, again, we haven't seen this, but it doesn't really matter, and has broken it down into smaller sub-problems. So when you have a big problem and you want to solve it, You break it into smaller subproblems that you try and solve. If they're still too big, you break them down again until they're easy to solve. Very, very powerful technique. But what's the name of that technique? The name is decomposition. You take a big idea, you break it into sub-problems or into smaller ideas, which might be broken down again, until you can solve all the individual problems, and then you'll solve the whole bigger problem piece by piece. Okay, we're moving on a little bit further now, and the problem we're looking at is going to be not asking us to write code at this stage, but to be able to read code. So this is some pseudocode, this is an algorithm, and part of what we're going to need to be able to do is figure out what's been asked of us in terms of what we've been asked to do. Okay, so let's have a quick read. So we've got a developer creates the algorithm shown in figure 8. So that's this algorithm here, to provide support for users of a new brand of computer monitor. Okay. So it outputs a message to the user on line 1, can you turn it on? Then the user responds in some way, and that's assigned to the variable ands. In fact, why don't we zoom in a bit so we can see it? Okay. If the answer equals no, so if they entered no, so no, I can't turn it on, it says, okay, the message is it plugged in? And then you respond again. And if you said yes, it has been plugged in, it says, okay, contact supplier. Otherwise, well, you should plug it in and then start again. Well, what happens if you didn't answer no? Well, if you didn't answer no, so let's say you said yes, for instance, you come down to this line. So you'd skip this bit and go to the else. And then it says, is it connected to the computer? If you said yes, contact supplier, else contact the computer. Okay. So this is using outputs, inputs, and if and else statements, which you can see here. Do you remember what that's about? That's selection. So this is sequence, one thing after another. Selection is actually, sometimes it will run this line, sometimes it will run this line. So it selects which bit. For the future, so when we get to there, the third thing was iteration, and iterations around loops. Oh, in fact, it's going to come up right now. Very handy. So let's review this first question. Okay. So shade one lozenge to show which programming technique is used on line 3. So this is line 3. Okay, so if ans equals no. Now, is that assignment? No. Assignment's this one here with the arrow. It's assigning the value. Okay, so that's not happening. Is it iteration? Now, do you remember I was just saying now, iteration is when it repeats. So that could be a while loop or a for loop or a repeat until loop, but none of those. It's selection because it's doing the if and else answers. So the next one we've got here is shade one lozenge to show the data type of the variable ands. So ands is going to be here. Is it a date? Well, one of the things it could be is no. So that's not a date. It's not expecting it to be. Is it an integer? You remember from the previous question, integer were whole numbers. So no, it's not that. Is it a real number? Well, a real number, as we discussed, is a number with decimal places. Again, no. Is it a string? Well, no or yes, that is a string. So we should write down here that it's a string. Okay. Regardless of what user inputs, the same number of output instructions will be always executed. So what it's saying is, no matter what the user inputs, right, whether it's yes or no, it will always do the same number of outputs. State how many output instructions will execute whenever the algorithm is run. So let's have a quick look. I'm going to highlight in, highlight in green every time we see it happen. So output, so that first output's always going to run. So that's 1. Then it's going to say, if answer is no, then do this, else do this. So it's saying it should always be the same. So let's assume they've answered no. So then it'll say, is it plugged in? So that second one, it's either going to be that one there, it's going to be that one there, or that one there. But we won't count both because only one is either going to run that because the answer was no, or it's going to run that. And then finally, it's going to do either this one here or this one here. So it's going to be a third one, okay? So the answer will be 3. Whoops. The answer will be 3. Hopefully I can do it properly this time. To prove that one's always going to happen. But let's say we answered yes. Then we come down here. Then it will output the second one. And let's say we said yes again, third one. So it's always going to be 3. Okay. The phrase contact supplier appears twice in the algorithm. So here and here. State the 2 possible sequence of user inputs that result in getting here or getting here. So I'm going to put a little red dot to say we're getting either here or here. How did we get there? So the first one, so sequence 1, is that you'd answer, and if the answer is no. So the first thing is that you'd answer no. So it will be ans equals no. And then, so that'll get you inside here. Is it plugged in? If you said yes, then it'll get you here. So the next thing will be ans equals, what was it? Yes. The second one is to get down here. So it's saying anything that's not no. Because its answer is no, then here. Here you could put down anything. It could be like blob, and then because it's not no, it's there. So ans equals anything. In fact, you could say not no. So it's anything but no. And then once you're in here, you'd have to say ans equals yellow. Ans equals yes. Gosh, what's wrong with me? To get to that one. All right, great stuff. Now, final bit. Another developer looks at the algorithm shown in figure 8 and makes the following statement. Okay, so we have to review this. At the moment, if the user enters Y or N, they will sometimes get unexpected results. So if they entered Y or N, so it says, can you turn it on? And you say Y instead of saying yes. Explain why this problem could have been avoided. Explain why this problem has occurred and describe what happens if a user entered Y or N instead of yes or no. You may include references, line numbers, but you do not need to include any additional code in your answer. So let's review. If I answer, so the first one here, answer, it's expecting me to say no. But if I said Y, then it's going to be this. So that's the equivalent of yes. What happens if I answered N? Is N the same as no? It won't be. So it'll still dip down here. So you could say something along the lines of line 3 only, in fact, why don't I say line 3 if statement only works with no string, as in the string being no. N will skip to line 11. You should accept N or no, as well as Y or yes. Because that way, for instance, here if it said if answer equals no or ans equals N, then do this. And maybe here you could even do else if for this one here. Or here, if answer equals yes or Y, for instance. Okay, we're now at the point where we're going to start writing some code. And it starts off really simple. On the right-hand side here, I've actually put some snippets of code that we can use. Again, we're going to start off basic inputs, outputs, variable assignment, and some basic if or if-else selection statements for comparison. Okay, let's read the question. The developer wants to use validation, so that's checking whether something's accurate. So it might be You know, it might ask you to put your age in, and is it between a minimum age and a maximum age? So it's trying to eliminate mistakes. To ensure that the user can only enter a positive number of eggs. So in this case, the number has to be, above 0, i.e. 1 egg or more. So you can't put down, you want to put in -3 eggs or 0 eggs in this case. The maximum number of eggs that can be used is 8. So the number needs between and inclusive of 1 and 8. Develop an algorithm using either pseudocode or a flowchart so that the number of eggs is validated to ensure the user is made to re-enter the number of eggs used until a valid number is entered. Now, I've not included it here, but if you keep on needing to enter it until it's right, you can't just use an if and else statement, because the if and else will only check once. You are going to have to do you are going to have to make use of indefinite iteration using either a while loop or a repeat until loop. Now, in this case, I'm going to use repeat until, I think. First of all, I'm going to ask the person, I'm going to write print. I'm going to ask the person, please, enter number of eggs. So I've done the statement here, please enter the number of eggs. Then I'm going to need a variable to store the response. It should be sensible name. So eggs makes sense, right? Because that's what we're doing. To assign, it's the arrow. And the command to getting somebody to input it is user input. Now, the color coding is not necessary if you do these questions. Just so you know, I use blue for commands like this. I use green for variables. I use black for kind of bits and pieces like this. And I use red normally for sort of stored values. But it's not necessary. And I also put commands in capitals to just distinguish, like they've done here. Is it necessary? No, it's not. Okay. So here I put in the number of eggs. Now I need this to keep going around until the number of eggs is between 1 and 8. So I'm going to use a repeat. So I'm going to repeat these lines of code. And then at the bottom here, until it's met the condition I want. See? And you see I've indented these two bits of code because these are the bits inside my loop. Well, until what's the case? Well, until eggs is greater than, now I could say greater than or equal to 1 or greater than 0. I'm going to say, let's say greater than or equal to, so that's that, 1. And then I also need to consider eggs is a less than or equal to, because it does include up until the maximum number of eggs that can be used is 8. So I can use 8 up until 8 eggs. Now the question is, what's the join that goes in between this? Now I could put in, for instance, I could say or. Now if it's or, if I put in, say, 5 eggs, is 5 equal to or above 1? Yeah, it is. So it'll finish. So that was a legitimate one. Is 10 eggs okay? No, 10 eggs. No, actually, let's go the other way. Let's do negative. I've said minus 5 eggs. So I put minus 5. Is minus 5 greater than or equal to 1? No, it's not. So that would be false. But is minus 5 less than or equal to 8? True. So it'd still be the case. So what we need to say is it's not just a case of or will need to be true. And so the way we'd write it is we'd say, and it's true. And so what's going to happen is it's going to keep asking these questions until this happens. The developer wants to use validation to ensure the user can only enter a positive number of eggs. Boom. The maximum of eggs is used as 8. Boom. Develop an algorithm to ensure the user is made to re-enter the number of eggs until a valid number is entered. You should tune in. Oh, done. Piece of cake. Okay. In this next problem now, it's going to be making use of a subroutine. So this is a snippet of code that we can call and run called code to char character. This can be used to convert a character code into the corresponding Unicode. So do you remember we talked about earlier about ASCII and Unicode? Well, if we put the number 97, it will turn it into a lowercase a. If we do 98, it'll be a lowercase b. If we do code to car 65, it'll be an upper A, 66, capital B, etc. Okay. The other way around, car to code, so lowercase a, will become 97. Car to code B will return 98, and so on. State the value that we return from the subroutine call of this. So car to code E. So if A is 65, we can just take our time to write it out. We're in no hurry. So we can say A, B, C, D, and E. We can see here that A is 65. So we'll write 65 down for here. And then we can see B is 66, C is 67, D is 68, and E is 69. So that would return 69, but plus 2. So the value that you would get is 71. And then code to car, so taking the code of 71 turn it back into a character. If 69 is E, 70 would be F, 71 would be G. So it would return G. Right? Because car to code E would return 69, add 2 to it, be 71, and you can see 70 would be F, 71 would be G, returns it there. Okay. Next, we're writing a subroutine. So write a subroutine to lower. So this way, they takes an uppercase character as a parameter. So it takes in a uppercase character and returns the lowercase version of it. For example, to lower is passed the character capital A and as a parameter, and it should return A. Okay, great. You should take the use of the subroutines code to car and char to code. So for a subroutine, I'm sorry I don't have it written with me right now, but to start off, you literally write the words subroutine. The next thing you need to write down is the name of the subroutine. And you see, you've got it here, to lower. And we want to write it out exactly as they want to do. So to, lowercase, lower. All in capitals, as they've said. Then it says it's taking in a character here. So I'm going to open up parentheses, and this is where the parameter will be here. So I'll say it will be, I need to give it a sensible name, so I can call it, let's call it char. So this is the value coming in. Maybe it's an uppercase D, maybe it's an uppercase F, whatever. Char comes in here. Now, do you see that what I'm going to need to do is if I receive a capital A, to turn it into a lowercase a, I'll have to turn it into a number, 65. What's the difference between 65 and 97? So we have to look at the difference. So 97 take away 65. So that's the difference in those two numbers. That's going to be 32. If my math's not wrong. So you take in char, you'd run car to code of it. You get the number, so 662. 65 in this case. Then you'd add 32 to 65 to make 97. And then you go code to char. 97, return it. So in here, we're going to say, first of all, we're going to run the first one, which was char to code. So we're going to call char undercase to lowercase or undercase. No? Yes. And then we're going to call it, and what we're going to send it, we're going to send it this char as a parameter here. So that's going to be char. I've written it too large. This is not sensible. I should have been a bit more careful. Oops, let's tidy that up a little bit, shall we? Let's be a bit more consistent. Now, remember what that's going to do is it's going to give you this number. Now, do you remember we said we need to add 32 to this to turn it into a lowercase, so plus 32. And maybe what we need to do is store that. So this is going to be a bit ugly. I should have indented this whole thing, but I'm a bit low in space. So I'm going to say, let's call this upper. And there's an arrow pointing towards it. So what's going to happen? Char comes in here. So let's say, for example, a B gets put into here. Then it's char to code B, so in here, and that would return 66. 66 plus 32 is going to give you 98. And then 98 is going to be stored. So upper is going to be 98. I then need to get 98 and then turn it back into a char. So here I can say, I could call it, next one maybe is upper C. What's that going to be? So that's going to be the other one. It's going to be code to char. And I'm going to send it the number. So I'm going to send it a number like here. I'm going to send it this number because this is actually going to be our number we're using. And I'll call it upper. I'll call it upper. I'll invoke upper. Now that will be our actual character. So then to finish off our subroutine, the last thing I just need to do is I actually just use the command return. And what will I return? I'll return this thing here because that will be our letter. Oh no, that is so silly. I've given this silly names because I called it upper C. It's not, is it? It's turning into the lower number. My apologies, guys. So we'll call it lower. And then I'm going to call this lower C. Now, this won't change the functionality, but you should always use appropriate names for variables. So writing upper would be confusing if I came back later. So a clear and unambiguous identifier is really smart. And then here I can return, in this case, lower C. And then I'll go end subroutine. There you go. I think really I wouldn't have done subroutine here. I've not read the problem, so this is probably in the wrong place. So if this has thrown you, we'll do some more selection problems next. So sorry about that.